Okay, welcome zoology. So today during this screencast, I'm going to lecture about 3 of the 5 classes that are in the phylum Echinodermata. And the general rule for taking notes today is if it's in red, you need to get it down in your notes. Okay, so you can see right here, these are the 3 classes that we're going to look at. Tomorrow when I see you or the next day, I'm going to give you more information about the other classes. The other thing that you're going to experience as you're going through this screencast is that there will be some pop-up quiz questions that you will get points for. So this is one way you get points for listening to the podcast. Just make sure you're taking good notes. If you don't know what the question is, kind of rewind, re-listen, and then go back to the question. You can definitely do that before you answer the question. Okay, so please make sure you're doing that. There's not a lot of them, but there is a couple throughout. The key thing that you're doing then is taking notes over the 3 classes that are in red and being able to show these to me because we're going to do an activity with them when I see you next class period. So you're taking notes today and answering questions from the video. All right? Okay, so those are the 3 classes we're going to talk about. So today we're going to talk a little bit about the class that sea urchins are in, and there's some slides after this that we're going to look at. The class that sea cucumbers are in, and the class that sea lilies and feather stars are in. Also, sand dollars are in the same class as sea urchins, okay? All right, so let's look at this class first. So let's get this name down, class Echinodermata, sorry. The 2 things I would write down from this slide, and I'm going to talk about each, is that this is where sea urchins reside. And if you don't know it by now, because we did watch a video, the animal at the top here, that's a sea urchin. So they have like these spines sticking out of them. And then sand dollars also reside in this class. And this middle picture is a picture of a sand dollar's test or skeleton that you might have found on a beach before. This is the dead version of the animal. So we're going to show you what it looks like alive too. And then just FYI, heart urchins are also in this class, and they're very much related to sand dollars. They probably all be in the same order, but we're not going to make a big deal about them. Okay? All right, so let's first look at our sea urchins. This is what you need to write down about sea urchins. First of all, I do want to get a picture in your head like what they look like. This is a nice little picture of a lot of them kind of gathering. I do want you to know that their skeleton is called a test. And we're going to talk a little bit about that. This test is basically like taking their arms and folding them in, and it makes this nice little test for them. And if you are a sea urchin, you have spines, and they're sharp and they're hollow. Some, not all sea urchins, are venomous because they contain some venom inside of them. So if you touch or step on them, it can be injected into your body. Okay? All right, so those are my sea urchins. My sea urchins. Skeleton is a test. Spines are sharp. They do have spines. Whereas a sand dollar, their spines are real soft. So what they do is they use their spines to burrow. So you find them burrowing a lot into the sand in the ocean. A lot of the times when you see these sand dollars, you see them dead because their skeletons are found on beaches. And that's the picture down below you can see right here. And they're cool to collect, but it's not the living creature. I want to show you really quickly what this living creature looks like. So if we go to this quick movie real fast, this is really what an actual sand dollar looks like when it's moving and grooving and alive. Now this one does have some sand on top of it, but it is moving. It's probably trying to get back to the ocean because they have to be in water. So you can kind of see that guy moving and grooving. Okay, and then I do want to show you their tube feet. So this is a picture of, that's the top of the animal. So when we flip the animal over, and this is a living one, again, see how it's brown, it has all this tissue on it. You can see their little tube feet moving. See them moving? That's how they move around. This is where their mouth is right here. We're going to talk a little bit about that. That little opening right there is their mouth. Okay, so that would be a living sand dollar. That's a living sand dollar. Okay. So to kind of sum up this class, here's the reason why sand dollars and sea urchins are both in the same class. And that is because they do have this thing called Aristotle's lantern. Both of them do. So let's get that definition down. It's the chewing apparatus that can be projected from the mouth. Now, this is a weird name for this structure. So let me just kind of give you some background information about it, just a little FYI. It was named after Aristotle, who, is the Greek philosopher from thousands of years ago. He was a scientist and a teacher, and he did write this book. And in his book, he actually described this mouth apparatus that sea urchins have as looking like a horn lantern. And during the time he wrote this, everyone knew what that meant. A horn lantern they had 5 sides to their lantern, so that makes sense. 5 sides. They were a 5-sided lantern made up of panels of very thin horn, and the horn was thin enough for light to shine through, but strong enough to protect the candle, because they didn't have electricity back then, from the wind. And so he described this in great detail, called it like a horn lantern. And then later, scientists just started to refer to urchin's mouth as Aristotle's lantern to kind of, recognize that Aristotle was the first person to kind of find this out. And the name just has stuck for thousands and thousands of years. So anyway, that's why it's called that. Let me show you some examples of Aristotle's lantern in sea urchins and sand dollars. So in a sea urchin, and we kind of saw this in our video, and you'll see this up close and personal because this is an animal we are dissecting. So this is the animal's mouth, and you can see coming out of the mouth are these 5, again, always 5, multiples of 5 in all echinoderms, teeth-like structures, and attached to it is Aristotle's lantern. So it is their feeding apparatus. Here is a sea urchin that has been dissected, and this is something we get to do in class. And when you get rid of all of its intestines and other organs, it becomes really clear what it looks like. It's this white hardened structure. It does look kind of like a lantern. And at the bottom here would be where his little teeth are, like these guys would be sticking out here at the bottom. So it is their feeding apparatus, okay? A better picture, like this is a diagram, so you can see all the other organs that sea urchins have, but again, can you see this white, big Aristotle's lantern? And you can see here how the teeth come out of the mouth for feeding. So this is something we get to see. I do want you to kind of understand it before we start dissection, though. If we compare that, though, to a sand dollar's Aristotle's lantern, everything about a sand dollar is flattened. It's like kind of taking a sea urchin and flattening it. I mean, that's not what happened. It's a completely different species. But because of that, can you see their Aristotle's lantern looks like a perfect star? It's real pretty. And this is another animal we're going to dissect. This one is dead, of course, and because it's nice and white. But if you do get lucky and you find this on the beach, if you crack it open, you might be able to see this little feeding apparatus that has been saved inside of its body. This is the bottom side of it. So like this is where its 5 little teeth-like structures would stick out to get food. So again, you'll see this in lab because we get to dissect a sand dollar too. The last thing about class Echinoderms is that they're both dioecious. So all sea urchins and sand dollars are dioecious. All right. Moving on to the next class. This class is the class that sea cucumbers are in. So let's write down this name right here. Okay. It's a big, long name. So I would write down the class name and say sea cucumber. Even though that's not in red, please get that down. Now, everything that's in red here, definitely get into your notes because this is what really distinguishes a sea cucumber from other echinoderms. And the number one thing is this is really the only echinoderm that has no arms. Instead, they have this elongated oral aboral axis. It's kind of like taking a sea urchin and stretching him out or it out. And so they don't really have any arm-like structures to them at all. But what they do have is lots of different types of tube feet. So they do have some tube feet. They have 3 to 5 rows of tube feet on one side, and that's used for attachment and movement. And then they have some tube feet that are around their mouth. Oops, sorry. So this is their mouth right here. Okay. And these are modified tube feet that we refer to as tentacles. All right. Again, this is an animal we are dissecting in class 2. So we're going to dissect lots of different types of echinoderms. All right. Let me just kind of show you another picture. Like that's the internal structure of a sea cucumber that we will be dissecting. The biggest thing about another thing that really stands out about being a sea cucumber is their madreporite is internal. And so that pop right there is where it is. What I was going to say is that you'll see this on a test because they're the only echinoderm that has an internal madreporite. And if you're still a little concerned about what a madreporite is or like a sieve plate, we're going to go over that in class a little bit more tomorrow, okay? Or the next time I see you. All right. The other really weird thing that these animals do have is something called a respiratory tree. So let's get down. Respiratory tree used for gas exchange. But here's what some of them can do with their respiratory tree. And if you look at it up here, it's this big yellow structure. And can you see how it is? Weirdly enough, even though it's used to get oxygen, it is directly connected to its anus. Okay. They don't have a lot of defense mechanisms because they're real soft. Unlike other echinoderms, these animals are real soft. They don't have any hard parts to them. So what some can do is they can evert their sticky web-like tubules from the respiratory tree, these guys right here, and expel them out of their anus. And when they do that, it kind of tangles up predators and makes predators like just confused. And then they usually leave the sea cucumber alone. So I'll show you a video of that. There's a little video here and here, but I'll show you a video of that when we get to class together. Okay, but I would just definitely write down they do have a respiratory tree and make sure you know what it's used for. And then they are also dioecious too. They're also dioecious. Okay, this is our last class then. Our last class that we're going to look at today is the class Crinoideae. And this is the class that we find sea lilies. So I'm going to show you an example of what they look like, and feather stars. And actually, this is the most primitive of all echinoderms. In fact, many of them really flourished during the Paleozoic era. And so some of them have become extinct also. In fact, one thing I would like you to write down is we have a Missouri state fossil here in Missouri. Our Missouri state fossil is a crinoid, which is basically a sea lily. And can someone tell me, maybe, if you don't have to tell me, but just kind of think like, why would that be? Could it be that probably, yes, our millions of years ago, the Missouri, this continent that we're on, like right in the middle of the United States, was probably underwater. It was a very shallow ocean. And this is why we can see this in the fossil record within limestone that we have here. So anytime you see rocks protruding out, like of the earth here in Missouri, that's usually some type of limestone. And if you go check it out, you could see lots of crinoids, lots of examples of these animals, fossils of them. Kind of cool. I will show you. I have some fossils. I'll show you when we get back to class, okay? But a couple more things we're going to write down. Sea lilies, and this is what probably lived here millions of years ago here. They attach permanently to substrate by a stalk, and they have a flattened disc or root-like extensions. So they don't really move, but how they get their food is they have tube feet up here, and they grab their food and eat it. Okay, what we usually see remnants of that are crinoids here that maybe lived here in Missouri are this little stalk-like structure. I'll show you some examples. All right, and then the last thing is a feather star. Feather stars, they lack a stalk. So this is how they're different than sea lilies. So that means that they can swim. And I'll show you a quick little video of them later on. We are not going to dissect either one of these creatures. So we're not dissecting a sea lily or a feather star. We're just going to talk a little bit about them. The last thing I'd like you to know about them that kind of sets them apart is they're the only echinoderm out there that does not have a nerve ring. So their nervous system lacks a nerve ring. They kind of have a different way of doing it. Okay, that is it. This is some stuff that we will be going over. I'm going to show you lots of these videos and some of the tutorial dissections we will help you with to kind of help you with tutorials. But other than that, that is it. I hope you did well on the quiz, and I hope you took some good notes today. Thanks.